Today's topic is Geometrical Isomerism Part 3. In the Part 1, Part 2, we discussed about cis trans and EZ nomenclature. Now, Geometrical Isomerism in oximes. Okay, it is similar to EZ nomenclature only, but in oxime shows geometrical isomerism due to restricted rotation about the double bond. Restricted rotation about the double bond. Of course, it is common in geometrical isomerism. Geometrical isomerism is raised due to restricted rotation between C double bond C. In the first class we discussed. Okay, in the second class we discussed same C double bond C, but here all four different groups A, B, C, D. Okay, in first class we discussed AB and AB. The condition is the sp2 carbon should be connected with two different substances. Either it may be atoms or group of atoms, right? Then only geometrical isomerism is possible. Then only geometrical isomerism is exhibit, right? Due to restricted rotation only it is forming. Only those oximes show geometrical isomerism in which sp2 carbon have two different groups. Same what we applied in the previous classes. So, oxime means what? This aldehyde and NH2 group is there in the chemistry wherever you will see the C double bond O and NH2 together, just you have to do remove the water molecule. Either it may be aldehyde or ketone. Okay, just you have to do H2O, remove the H2O. It is forming double bond N, C double bond N. So, especially here, this C double bond NOH is called oximes. This is called oxime. Right. Now, we will see how to give this nomenclature. Is it cis? First class cis trans we discussed. Then second class EZ. Now we are going to discuss syn and ante. Syn and ante. It is a part 3. So similarity I will show you. Cis equal to Z equal to syn. Okay. Then trans equal to enemy opposite side equal to here anti opposite side like this. Okay, you can link up like this. Cis when we are using same groups, methyl, methyl same side, hydrogen, hydrogen same side is there. Then Z highly preference group same side is there. Z. Syn now we are going to discuss. So once if it is forming oxime, this oxime structure we can write two types. Here H and OH both are same side. Here H, OH both are opposite side. Okay. Now with respect with respective of HOH we are giving this name syn and ante. When HOH are of the same side, that is syn, then HOH are on the opposite side, then we are giving the name is ante, right? So benzoyl oxime we can write syn and ante. HOH opposite, so ante, HOH same, so syn, right? Understood? Next, which of the following show geometrical isomerism? See, for the showing geometrical isomerism, the sp2 carbon should be connected with two different groups. Okay, so this is the sp2 carbon. Here methyl is there, here also methyl, so it won't be. Okay, this is the sp2 carbon. one is hydrogen, then other one is ethyl is there, so it can show. Next here it cannot show, two hydrogens are there. This is the sp2 carbon, one side methyl, one side ethyl is there, so it can show. So answer is AD, right? Next, this geometrical isomerism exhibited by azo compounds also. What are the azo compounds? Azo compound means where N double bond N compounds, azo compounds. Here, with respect to of lone pair, we have to see similarity is there, same side is there, that is syn. If lone pair is opposite side is there, and this is azobenzene. Next, geometrical isomerism, it can exhibit by cycloalkanes also. There is no double bond here, but even though it is existing, because this ring also considered as a double bond. Cycloalkanes show geometrical isomers due to restricted rotation about a single bond. Here, the single bond cannot rotate. This cannot rotate. So only those cycloalkanes show geometrical isomers in which at least two different carbons have two different groups. That criteria is same. Starting say, okay. Previously we talked about this sp2 carbon should be connected with two different groups. Now we are talking about these carbons should be connected with different groups. Okay. Here both side upside methyl is there cis, and opposite is there trans, again cis trans nomenclature. Okay, so chlorine downside is there, so cis. Which of the following show geometrical isomerism? First of all, these are showing the geometrical isomerism in that cis. Here chlorine and hydrogen, yeah, chlorine and hydrogen same cis type. Then if you take this one, see these, just you assume the ये दोनों के बीच में double bond like this. So hydrogen and hydrogen, obviously it cannot. So here double bond in between. Suppose any you take any two. So this is a one bond. So a pura ring you can assume one more bond, right? So this carbon, see I'm writing here. This carbon methyl is there. Here ring is there, right? This carbon also methyl is there. Here ring is there. So see, same side is there methyl, so it is cis. Okay, here it is cis. If I talk about here, of course cis. Here, of course, it is cis. So geometrical isomerism is possible, right? Number of geometrical isomers in polyenes. If more than one double bonds are there, how can we calculate how many isomers are possible? See here I told 3 3 cis I written. So like that, how many isomers are forming? So here one formula is there, two formulas are there. R1 means कोई भी alkyl group, CH double bond CH, right? Like this bigger chain is there. Here so many alkenes double bonds are there. If the condition is here, R1 is not equal to R2, means here suppose methyl is there, it should be here ethyl like this. In that case, the number of geometrical isomers equal to 2 to the power of n is the formula. What is n here? N is the number of double bonds. Number of double bond means here one position, 1, 2, like this, dash, 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 here, n. So, how many are there? Those 2 to the power of n isomers are possible. Now, example 1, here 1 double bond, 2 double bond, 3 double bonds. So, 2 to the power of 3, that means 8 isomers are possible. Okay, can we write this 8? We'll try, right? Here 1 double bond, then double bond, then double bond. These two should be different. Here it is ethyl group, Here only methyl group. R and R dash, different groups. Now the formula is 2 to the power of 3, that equal 8 isomers are possible. What those 8 isomers? So it is cis, cis, cis. One possibility is there, right? Cis, cis, trans, cis, cis, sorry, cis, trans, cis, then trans, cis, cis. How many over? 2, 3, 4 over. Now with yellow color I will write cis. नहीं ठीक है. Now I will write here. ठीक है. Cis, trans, trans, two transes. Yes. I can do one thing here. Wherever trans is there, trans के जगह पे cis के जगह पे trans. That is a better. Okay. Uh, Easy to understand that. Now, one is all trans, 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 cis, trans, cis, trans. Now, cis, trans, trans. Okay. 4 plus 4, total 8. All are different, you can see. So, like this. Suppose if R1 equal to R2, both are same, then 2 to the power of n minus 1 plus 2 to the power of n by 2 minus 1. N by 2 minus 1. Here it is not exactly n by 2 minus 1. Here it is written that p minus 1. What is p? P means for, see, actually n by 2. But odd number means fraction value it will come. Odd value. So that's why for odd value what we are taking n plus 1 by 2. N plus 1 by 2. For even number exactly we can do fraction n by 2. Like that you have to remember. So 2 to the power of n minus 1 plus 2 to the power of n by 2 minus 1 for even number, 2 to the power of n plus 1 by 2 minus 1 for odd number. Okay. Now why we are taking n plus 1 means it should not come fraction value. Like that you can remember easily. Okay. Otherwise, suppose 3 carbons are there, 3 by 2 means 1.5, 2 to the power of 1.5 means it's very difficult. So plus 1. Now 1, 2, 3. Here methyl is there, here methyl is there. Both are same. So in that case, which formula we are using? 2 to the power of n minus 1 plus 2 to the power of p minus 1. Here, this is the odd number. In case of odd number, the p equal to n plus 1 by 2. So 2 to the power of n minus 1 by 2, 2 to the power of 3 minus 2 to the power of n minus 1 plus 2 to the power of n plus 1 by 2. Right? How many are there? So then 2 square plus 2 to the power of, again 4 by 2 means 2 square. Sorry, 2 to the power of n minus. Okay, n plus 1 is odd number, right? 4 by 2. It should be 2. Okay, minus 1 you forgot it. The formula minus 1 is there, right? 2 to the power of p minus 1. Right? P minus 1. Then 2 square, that means 4 plus 2, that equal 6. Okay. Formula, just you remember the formula. Formula is for even number of double bonds are there, 2 to the power of n minus 1 plus 2 to the power of n by 2 minus 1. Once you see that, yes, 2 to the power of n minus 1 plus 2 to the power of n by 2 minus 1. For odd number of double bonds, 2 to the power of n minus 1 plus 2 to the power of n plus 1 by 2 minus 1 is as it is. Okay, next. So 1, 2 bonds are there. So 1, 3 butadiene show geometrical isomerism due to resonance. Due to resonance, it is showing. So what is the resonance here? See here, this pi bond is shifted here, this pi bond is shifted here. It's a negative charge, here is a positive charge. So this is the structure. So in this structure, you can see hydrogen is with respect to this double bond. One side hydrogen, one side CH2 plus. One side hydrogen, one side CH2 minus. So hydrogen, hydrogen same side is there, cis. Hydrogen, hydrogen opposite side is there, trans. If you don't know about this resonance, we can say that here sp2 carbon has two hydrogens, same. So not showing, it is also not showing. So total is not showing. But resonance, resonance is showing. So finally this compound is exhibiting geometrical isomerism. Right? Optical isomerism in the next class. These are the questions. These are completed. Now see, last few points I want to tell you. Okay, here, what is the purpose? Why we learn this EZ nomenclature and these things? So this is important here. One thing is how to give the IUPAC name. How to give the IUPAC name. Here, these two are there. So both are but2ene. But2ene. So both. So how can we distinguish here? The first one is cis but2ene. The second one is trans but2ene. So this is the one name difference. Next, the uses physical and chemical properties. Generally physical properties. The first one is dipole moment. The dipole moment is in generally cis is major than trans. Cis isomer has resultant of dipole moment, while trans isomer dipole moment will be get cancelled, zero. Okay, boiling point. What is the dipole moment? See, dipole moment is symbol is mu. Mu equal charge into density. Charge into bond length. Charge into bond length. Okay, suppose H plus Cl minus. Cl minus. Here, this charge is not complete one charge. Here, partially. These charges are partially charges. So, dipole moment is there for HCl. This partial charge into this bond length. How much bond length is there? That's bond length. Okay, like this we will calculate dipole moment. So this dipole moment is a vector quantity. Dipole moment is vector quantity. So vector quantity means it is depends on the direction. Suppose C double bond O, C double bond O is there. Is it polar or non-polar? Anyone can tell? It is polar or non-polar. See, electron negativity difference is there, so partially negative charge, partially positive charge. Again here partially negative charge, partially positive charge. But these forces are, this is theoretical, but these forces are acting like this. Here it is pulling electrons, here it is pulling. So resultant get cancelled. So no polarity, no polarity. But in case of water molecule is bent structure, bent structure. That's why, see, the force is the electron. It's like this. Here it is like this. Okay. The resultant force is you will learn perfectly in the physics vectors one. Okay. If one force is acting like this, other force is acting like this, the resultant force will be like this. Suppose one force and other forces are opposite direction, then it will be get cancelled, zero. In this case also, it will be get zero, right? This is the dipole moment, is a vector quantity. Now, if we go, one example I will give you. Hydrogen and methyl is there, methyl. So dipole moment, see this dipole moment. This is the sp2 carbon, electron negativity is more. Here also sp2 carbon, electron negativity is more. So the electron movement is towards sp2 carbon like this. This one is like this. So the resultant force is like this. Just if you assume it is one molecule spherical shape, in the 50% downside is positive charge, upside is negative charge. So finally mu is not equal to 0. So therefore it is polar molecule. Polar. If you take the trans compound, if you take trans compound CH3 H CH3 H is there. So in this case, the electron force is like this and it is like this. So get cancelled. Here mu is equal to 0. Okay. So this is the about dipole moment. From this, how can the boiling point and melting point will be vary? Okay. See, boiling point means what? Here, so many molecules are there, one molecule. So boiling point means this surface molecule is gets separated into the vapor. Okay. Suppose if it is the polar nature, while this molecule is escaping from this surface, this one is pulling. Okay. So obviously it is not ready to escape from the surface. So the boiling point will be increases. We have to heat more temperature to boil that. In case of one molecule is there, other molecule beach में just only van der Waals forces are there. There is no attraction. In that case, easily it can escape. So boiling point will be less. So cis boiling point is higher than trans. This is the reason. Okay, cis boiling point is higher than trans. Then solubility also cis is higher than trans because it's a polar. Cis is the polar. Cis polar, the polar will dissolve in the polar solvent like in water. That's why I mentioned here in water only. We are not talking about other organic solvents. Melting point, boiling point over melting point. This melting point is depends on the symmetry. I will explain. Next, stability. Trans, stability and melting point I will tell you. See, melting point you can see once you read this. More symmetric isomers have higher melting point due to better packing in crystalline lattice. Trans isomers are more symmetric than cis. This is the reason. Stability, the molecules having more van der Waals strain are less stable. Cis isomer, the bulky groups are closer. They have larger van der Waals strain. Okay, I will explain with example. The first one is if you take the stability, suppose methyl group is there, double bond. ये दोनों का steric tendency is there. In case of trans, the methyl group above, the methyl group is below. no strain, no strain means repulsions, so therefore it is stable. Okay, it is less stable. Next, what we are talking about, next one is solubility over. Next uh, stability. Okay, melting point. Next melting point is, this is the cis and this is the trans. So if I take so many molecules, so trans is like this, just like in one chairs. Okay, we can arrange chairs one upon one like the 10 chairs, but it is just like table. Okay, one table, another table, another table, another table. If you apply some force, if you do one punch on these, all tables will fall down, but your chair cannot fall down. If it is fall down also, these molecules together, these are not get separate. Here these benches are getting separate. Okay, so one molecule is not inserted in another molecule. Here properly arranged, one is inserted in another. So that's why the melting point is higher, here melting point is lower. Right? This is the advantage of this melting point, and physical properties we can explain by this cis and trans. You can see 2 3 examples. Cis, mu is not equal to 0. See, here it's going like this. If you assume this is a molecule, here positive charge, negative charge. In this case, opposite direction get cancelled, mu equal to 0. Okay. Now, if dipole moment of chlorobenzene is mu, then the dipole moment of this one, see all three forces like this, like this, like this, triangular shape. So resultant is 0. Okay. And one important question, JEE and NEET question is, methyl chloride and chlorobenzene, which has more dipole moment. Okay, 1 and 2. So methyl chloride has higher dipole moment than chlorobenzene. Why? What is the reason? So the reason is here, this carbon is negative, chlorine is negative charge, carbon is positive charge. But here, in the resonance structure, कभी positive रहता है, कभी negative रहता है. So benzene ring is getting negative charge. Okay, is it fixed? No, it is also not fixed. Due to the resonance, again, sometimes it is a neutral also. Okay, it is neutral and positive charge. That's why this is the higher dipole moment than chlorobenzene. Okay, if you have any doubts, then you can ask in the comments.